Okay, YouTube, I'm gonna update you on my system. Today is minus 10 outside. um, I cannot stay too long. um, I'm just gonna talk about my heat pump system, right? So this heat pump, it outputs 60,000 BTU. If I'm looking at the rating here, 18 kilowatt is what it consumes, and I was told it outputs up to 60,000 BTU per hour. I'm trying to find that somewhere. I don't think there's a BTU rating, but that's what outputs. Okay, so I can't stay too long here. 18, it consumes 8.51 kilowatt and produces 18.5 kilowatts of energy. That's around over 60,000 BTU per hour. My house is rated to consume around 32,000 BTU per hour because of the ICF. If it wasn't for the ICF, it would have been 100,000 BTU per hour. So you ask me, at minus 10, this one will produce half what it's rated for. It goes up to minus 20. After minus 20, it shuts off. So you ask, why did you get heat pump? Well, this heat pump, it also does AC in the summertime. So I save a ton of money by not purchasing other systems, air handlers and stuff like that. I'll just use the same radiant system to heat and cool my house. So eventually I plan to have a solar collector. One solar collector panel will produce 2.5 kilowatt, I was told. So I need 4 of them, 10 kilowatts. 10 kilowatts of energy would provide my heating consumption, will meet the demands of the heat of the house. So that boiler, I made a mistake and I shorted a circuit, and that boiler is out of service now. So today, on Monday, it's going to minus 20. The heat pump outside will shut down. This house will be cold. So I have to rush and fix that boiler. So I knew what I messed up. So I'm constantly following the temperature. So I ordered, I'll show you, this module. And the company sent me the Thermolock, the boiler company, sent me the wrong, wait in it, the wrong module. So this is for the older version. The other one hopefully will arrive today, the correct one, and I'll quickly replace it. That one produces 1.5 kilowatt, produces 37,000 BTU. Right now, as it is, this is not enough to heat my house, because like I said, I have nothing upstairs. All of my heat goes up through here. Majority of my heat losses through this wall here. 2 big windows, that's 9.5 feet wide window. Same down below here. I feel all the cold coming through there. All right, so if I stand over there, not much, the temperature is really nice. But if I sit here, I need a blanket because all the cold comes here. And right now at minus 10, the heat pump outside cannot keep up. It only can produce a temperature of 31 Celsius, whereas I need up to 40 or 45 Celsius to heat the house. So, and when it gets to minus 20, it shuts off completely. So if I run the boiler is also doesn't produce that much, but it's constant. It wouldn't shut off even at minus. I'll have some heat. Hopefully I'll survive. I kind of want to talk about these batt insulations. So you can see here, this batt insulation is full, like it's full of, it has not shrunk. The reason why is because outside we put ICF foams, and then we really spray foam it so there's no air can get in. Because there's no air can get in here, these things do not shrink. If they don't shrink, they keep the insulation value. Whereas if you're building a wood construction house, the OSB sheets or a plywood sheet in the outside will has holes. So through these holes, air come in. If you watched my last videos, air will come in into this cavity, and then it will also suck out all the heat out. It will come in, it will suck out. So you will see in inflating and sucking action going on. I didn't see that on this wall because it's well insulated. Whereas that wall over there, that wall over there, I mean that section that I had to fill up when I put batt insulation, there was air getting in and it was sucking all the heat out of the house. And because it was sucking it from over there, it was also all the air was traveling from this door and coming to this area, making us a little bit uncomfortable. So I placed rigid foam inside, you can see, and I foamed it with spray foam, so there's no air getting in there, so I'm not losing any air. So I improved a lot. So I am so happy that I moved in the winter time, because I can find where air is escaping and I can shut it off. And I learned about these batt insulations. So I'm glad I built ICF wall, because absolutely there's no heat transfer with ICF wall. When I was living in a wood constructed house and I touched the wall on, I mean, it's only drywall, and then wood construction house, if I give you an example, right? It would just be the outside wall is, instead of 2x4, it would be 2x6. One side drywall, that's what I spray. The other side is the OSB sheet. In between is insulation, but air comes in through easily. And then if I touch the drywalls once in a while, I would feel the heat, the cold air coming from outside. But whereas with ICF, nothing. It feels just warm. Even upstairs here, I don't feel any cold on the wall here, right? So the only way heat transfers in this building is through the windows, right? So I worked hard to keep the air out, but the heat transfer only happens through the glass, right? I can feel it a little bit cold through the glass. This is triple pane glass, but still be air loss. I mean heat loss through here, but air loss because it's foamed really well. There won't be any air loss. So that's the other window I was talking about. Like I said, upstairs, I taped everywhere. All this is a new taping here. So it improved my heat loss dramatically. I used to feel cold at -4 up here, but now I don't feel any cold at all. It feels nice. I have some areas I still have to do. Like I have to seal, I'm sure there's heat loss over here. So I gotta fix that one. Once I fix that, pretty much don't have any heat losses anywhere, because I foamed as much as I can. What I'm gonna do is I'm gonna get a candle, go around and check. Pierre, my friend, told me to use candle to find air leaks. So if I control the air leak, I will save a lot of heat transfer. So I need less energy to meet the demand of the house. The other thing is I was telling you about, I have these fan coils. I didn't want to open them up right now because the house is under construction, all dust getting in will damage it. I'm supposed to have one of these water fan coil over there, or just below the window, and I have another one also sitting somewhere, I think, over there, and that one is going to sit, eventually it will be a balcony door there, 8-foot balcony door, and it will sit just over there, right? And so I have two of these, and then one smaller ones per every bedroom. So that would be 2 + 4, 4 bedrooms, 6. And there will be eventually be a wall here and right here, and I will have one of them. So 7 of them. So the 11 kilowatt boiler would keep up with the demand of the house much easily once I have those fan coils installed. But because I don't have those fan coils, 7 heating devices, because I don't have that, I don't have enough heat to keep warm in winter. On Monday, it's forecasted it's gonna get minus 23. I probably have to leave this house. It's gonna get really cold. Last time, it got to minus 20 last Monday, and the house temperature downstairs. So when I'm talking about the outside temperature, I'm talking about in Celsius, minus 20 Celsius, minus 10 Celsius. But my thermostat here is set at Fahrenheit. So I have to tell you in Fahrenheit. I don't want to do the calculation. So in Fahrenheit, inside the house, last time, it got to 62 and 61, I think. And that was cold for us, 62, 61. But 69, 70 is actually nice. Right now, it's minus 10 outside, minus 10 Celsius. And then here is 69 Fahrenheit with 85. 80, it was 84. The concrete was at 84. There's a sensor, concrete sensor here that reads the concrete temperature. So the concrete temperature was at 84. It was 85 yesterday. So we'll keep going down. The temperature is going to go down to minus 23 Celsius outside by Monday. Today and tomorrow sits around minus 16. So we're going to be cold. This temperature is going to go down. Last time when it was minus 20, it went down all the way to 61 and was very cold. It's very uncomfortable to stay in the house. So you can see a lot of this area is not insulated now. This landing is not insulated, and the floor does not have any heating. There's no tubes underneath that floor, just concrete. So this area is cold, and that cold will travel toward us here. If there's any leak, because it will leak out, it will suck it out, and so that's why it will be cold. I'm hoping I can fix that boiler. I purchased 18 kilowatt boiler. It was only like $500 of difference between 11 kilowatt and 18 kilowatt, but the company will not return that for me, that 11 kilowatt. So what I will do is I will fix it with that part which arrives today. Once I fix it, and if it works, I will test it with minus 23, how it will do. And if it does okay, I mean, I can be patient. It's just January temperature. By February, the temperature should be okay, because the heat pump outside will run just fine up to minus 8, minus 4 runs great. Up to minus 8, it runs just fine. And with the fan coils upstairs, that should improve everything dramatically, right? So I don't really need the 18 kilowatt boiler from Thermalock, because I can, I can be patient, ride out the weather for minus 23, and then by next summer when I have all those fan coils in, it should be fine. So I plan not to use it, but if things go really bad, I probably have to replace that boiler for 11 kilowatts of energy, which would provide 60,000 BTU, which would be enough to heat the house without the fan coils upstairs. So that means that those fan coils, when I have them installed, they will run at very, very low energy. And then eventually I should be able to produce up to 11 kilowatts. The plan is to produce up to 11 kilowatts of solar energy using a solar collector outside. Each panels of solar collector will produce 2.5 kilowatt. 2.5, 4 of them, more than enough. Like it's almost the same size of a single solar panel, will produce 2.5 kilowatt. And 2.5 kilowatts, 11 kilowatts, it will meet the heating demand of my house. And the plan is to have another solar panel system later in a few years, and to go up to 10 kilowatts. So I'll probably be producing energy to sell to the grid system, and would probably make me money when everything is settled. That's the plan I have, and that's why I'm being patient. The other thing, the cool thing about uh, the heat pump outside is that these concrete floors, if I by using the cool air, cooling the concrete in the summertime, I need extremely low amount of energy to keep this house cool, right? Um, so if this house stays with little amount of energy, I can keep it cool using the heat pump outside and saving more money for electrical energy. And so this was my main goal, to keep the house extremely efficient, so that it's easy to maintain. Right now you can see we don't have much around here. In about during March time, I plan to put the IKEA panels that you may have seen upstairs, and then hopefully once I have kitchen upstairs, we'll move up upstairs. All right, so I think I covered what I want to cover. I will probably update you how I did for when it got to minus 23 Celsius outside, and I'm finger crossed. I'm waiting whether I can survive in this house at minus 23 with that 11 kilowatts of power with no fan coils upstairs. This is pretty much an experiment to see if that's going to be okay or not. I guess I'll find out. The temperatures Tuesday, it gets to minus 23, and then it goes up to minus 4, and I should be okay the rest of the weeks. I checked the forecast. It looks okay, so I should be okay after that. But I need to survive Monday, Tuesday. Okay, thank you.